right, Noorain, thanks so much for coming on. I'm looking forward to this talk. We've been talking about it for a while.
Absolutely.
Sweet. So first, I want to get to know you a little bit. Like I know the stuff you're doing now, but what kind of led you to this path? Because I know you did a lot of DevOps stuff. I know you did, a lot of like Go stuff. So
Yeah.
kind of walk me through your path a little bit.
Oh my God. Okay. So I don't come from a computer science background. I come from an electronics background, and I know your past guest comes from an electronics background as well. So my career started with programming little chips. We call it firmware development in C. So that's where it started.
I did firmware too. Yeah.
Oh my God, really? So that led me to IoT.
Right.
And IoT has cloud is like a big component of IoT, right? And I was like, oh my God, I want to build a database which can scale to the maximum, like to Facebook scale, And that led me to the path of cloud computing, where I got introduced to Node.js and Go. And eventually I got so fascinated by orchestration that eventually I landed my way to the Kubernetes world. And yeah, I had a complete startup, which was like a Firebase plus Heroku platform mashed into one. Got absorbed by this bigger company, which got me into platform engineering. So we made a lot of abstraction on top of Kubernetes. And then eventually, GenAI hit us all. And people were like, no, we need you to start thinking about products on this line. Right. So yeah, had to self-learn GenAI, and here we are today.
Nice. So let's say, coming from your firmware background and DevOps, coming from that cycle, what do you think, how do you think that relates to GenAI? Like, how does it make you think about GenAI applications maybe differently than someone who either comes from the machine learning world or maybe comes from a more traditional software development world?
Actually, this is a really good question, because so there are two kinds of people coming into the GenAI space right now, right? Actually, three kinds. People from the data science world, people from the engineering world, like the data engineering world, like people who do big data, and the software, the full stack guys. Everybody looks at GenAI with a different lens. And my background mostly has been on the data engineering and software development, or the full stack development side of things, for most of my career, keeping firmware aside. I think you start thinking of GenAI more as an application concern rather than a science. Right? And that completely changes the way you look at things. Like paradigms like agents, paradigms like MCP, they just feel natural to me because that's engineering on top of LLMs, right? Those are engineering solutions. Right. So I think having that engineering lens more than anything else is a bigger impact, because a lot of folks from science, I think they miss that out maybe. Or maybe they don't have the same perspective. So, and I feel GenAI has shifted the balance in the sense that AI is now going to be more of an application concern. It's going to be used by devs to build apps rather than, folks are using data to train things. Right. So that barrier is shifting, and I think engineering is going to play an even more important role in how GenAI is consumed to build applications.
The other thing is, which you touched on interestingly, is just if you have firmware, you had a lot to deal with state machines a lot, right? And it seems like everybody's now touching on state machines, but in a different way. And it's cool coming from like a background where, I know about like Mealy state machines, like what type of state machines, and then corresponding that. How do you think that style, like state machine development, translates to, architectures we see now in GenAI applications?
So I mean, I don't even know how to answer this one, but I think my first conscious interaction with state machines, like consciously interacting that, okay, this is a state machine, was in the front end space. It was Redux. So, I mean, state management on the front end is a very hard problem till date. I mean, nobody gets it right.
I hate it, man. I hate it.
Nobody gets it right. So Redux was trying to solve it in its own obscure way, and it had the paradigm of introducing action dispatchers and reducers, and the only people who got Redux right were the people who understood that this is a state machine. Like a reducer takes a state and returns a new state. React works in a very similar way, right? It's immutable. The moment you get into immutable state going from one form to the other form, it's a state machine. That just changed the way I think about things. And then once I got into the cloud, I looked at AWS state step functions. AWS step function, that's a state machine as well. Yeah. So essentially, state machine is just a way to move from one state to another, right? In a predictable way, in a replayable way. Like you can rewind it, you can play ahead, you can do all of those fancy stuff. So I think more than the AI space is fuzzing that logic a lot, because the core is just going from one state to another state. And I think AI is using it for orchestration more than anything else. That's one such use case. That's not the use case. So I think a lot of these tools which have started to adopt state machines like your pydantic graphs and lang graphs, it's good, but we need to understand that state machines are capable of a lot more, and there are a lot of different patterns that you can use it with. Right? Graphs is one of them.
Yeah.
So I've got some apprehensions there. I'm not saying it's a bad move, but I think it's more important to understand what's happening under the hood. And that's critical more than just the framework itself.
Yeah, got it. So we kind of touched on it a little bit there, but I want to hear your definition here. The key question, $1 million question right now.
Oh my God.
Noorain, what is an agent?
Holy.
From your perspective.
So can I take a longer route for this one?
You can, yeah, absolutely.
Okay. So I think on my streams, I try to answer or try to mess around with agents a lot. Like, what's the definition of agents, and push the boundaries of it. But what I've realized is the best way to communicate what an agent is to understand why it is. Right? So when you're interacting with LLMs, we just started, ChatGPT hit us and we were like, wow, this is amazing. But what eventually happened is we started pushing the boundaries of an LLM, right? It started with just a chatbot, and then we started doing things like structured responses, right? Get JSON so we can make decision based on those responses. Or we started doing like, okay, here's a lot of data. Here's a user's question. Try to figure out from this data what's the right answer. In context learning, which leads to RAG, right? So now we're pushing the boundaries of an LLM. But here we introduce problems. Because what if the LLM makes a mistake, right? For example, you're trying to generate a SQL query. Sure, it's going to get it right most of the time, but as your data model becomes more complex, it's going to make mistakes. So now you're going to get into a situation where the LLM gives you a SQL query, but you're going to have to validate the query. You'll have to like run it against the database and see if it compiles, or if it actually executes, or if it returns something, right? What if it doesn't? You'd have to go back to the LLM and be like, hey, you know what? Can you fix this? Now you're getting into having a conversation with the LLM and nudge it towards the right direction.
Right.
So my question would be, is the LLM prompt by itself good enough? Probably not. It's this loop around it which is critical to using LLMs in a reliable way. Now this loop, what I call the reasoning loop, has to be given an abstraction, has to be given a name. Because you can't just use LLM prompts anymore. I mean, you can use some of them, but like I said, some kind of a loop is required. Validation is one such example. There could be a lot more. Now, agents is a way to abstract these loops. So an agentic system is just a function with a while loop, which is doing an LLM call, probably doing some logic, trying to see if there's some flaws with it. If yes, go back, nudge the agent again. This is a simplified loop. There could be more nuances there, but essentially it's a loop. But now you'll get into a problem that, okay, is a function just an agent? Is just a loop? As an engineer, you need some kind of a standard on how do you interact with it. Sure, you make your own. Yeah. But even when you work with HTTP, it's not chaos, right? You create your own open API schemas, you create your REST endpoints, and then you create your definitions and your standards, and you're like, okay, this is how we're going to use it, right? So those functions need some kind of standardization as well. I'm not saying standard on an industry level, but at least on your use case level or your project level. Yeah. That's where the concept of an agent comes in, according to me. So agent is just a function with a reasoning loop.
Yeah. So it's interesting because for agent, let's just step back in there, because my kind of foray into agents was, okay, RL agents, right? So you have an agent, reinforcement learning. So an agent that interacts with an environment, you're trying to maximize the reward function, right?
Sure.
And it's still in AI land, and actually now you're seeing models use RL, so it's getting all confusing now.
Of course.
So you see papers where like it's making agents and it's using agents to do it.
Right.
And then, so I was always trying to wrestle with that definition of like something interacting with an environment to maximize the reward as an agent model. But it doesn't necessarily apply to these agents, these LLM agents, because it's like, you have something that's indeterministic, right?
Yeah.
Some stochastic process, and then you're trying to attach some output to it. So like my definition personally is like you'd have an input to a stochastic process, and then there's going to be some sort of output there, and that process itself through is an agent.
Precisely.
It is there, but like it falls apart too sometimes, because it's like, at what point what's the minimum agent, right? Like, what is is an LLM call let's say I have something that makes an LLM call and then returns a function. Just one function call, LLM call, returns a function. Do you define that as an agent too?
Yep. That's again, great question. Oh my God, you're making me think here. This is not a new question. Like in the microservices space, how micro is a service, right? Is one API a microservice? Is 10 APIs a microservice? How small can a microservice be? You can flip it over. How fat could a microservice be? Okay, that doesn't sound right. How big could a microservice be, right? Does it have to have REST APIs? What if it's just, listening to events and doesn't even have an API? Is that still a microservice? The point is, let's go back to why we came about with the concept of microservices. It was for each dev team owning their own process, owning their language, owning their DevOps process, blah, blah, blah. Similar with agents. What's the point of an agent? Like I said, we want to make LLMs more reliable. That's the problem statement I truly believe needs a lot of work on, right? Make LLMs work reliably in a software stack. Because when you have a database and your database doesn't give you a proper answer based on a SQL query, you would flip it over. Why do we allow LLMs to give us incorrect answers? That shouldn't be allowed. And of course, there's some engineering or some conditioning or a reasoning loop required to, try and get the best answer. Of course, you might not get it every single time. It's not going to be 100%. But whatever abstraction you need to get the best answer possible is the agent. If it's just an LLM call and that's good enough for you, call that an agent. If you think you need a while loop which, generates a SQL query, tries it out in a database, if it's not, go back with the error and go like, hey, this table does not exist, fix it. It does something. And you try it again. Oh, this column does not exist. Go back. It tries again. Oh, got it right. Perfect. Return it now. If that's what it takes, that's an agent. So I wouldn't go into the depths of defining exactly how big or small it needs to be. Right. I'll try to be with the spirit of an agent, which is take an LLM call or an LLM prompt and add some engineering around it, which makes it more reliable. Anything which makes it more reliable and makes it good enough is an agent. Nice. But I think I really love the way you put it. It takes an input and it takes an out and it gives back an output, right? In the engineering world, that's what we call a function.
Yeah, it's true. There is a concept of agents as functions, and I've seen actually a local kid actually showed me a library. I think it was Tiny Toon, and it was like he was using the concept of functions as agents.
Oh yeah, he showed it to me as well.
Rishit, yeah. So that was an interesting I haven't used the library much, but it was an interesting way of me thinking about it, where it's like agents as functions. But then there's also the DAG thing, right? Which is always a really interesting part. And we had this discussion even this morning, where it's like, if you have an entry point to some system and you're doing whatever it is, traversals, or you have an output state,
right?
That could be the agent. But then Prashant, who we got to shout out Prashant. I think maybe give a shout out to Prashant.
Absolutely.
While
love
I mention
you, Prashant.
Him.
We love you, Prashant.
Yeah. So Prashant Rao, he's incredible engineer. He helps us out quite a bit. I know he's on your stream and we'll get into that a little bit. But because he was saying how, the node traversals not necessarily is not always what the agent does, because new nodes can also be defined by the agent, right?
Yeah.
So we have a self-healing system where now nodes are defined by the agent.
Right.
But then there still has to be some abstraction. And my abstraction is the entry point and then the exit point. At least those have to be somewhat defined. Otherwise, you just have a loop of LM doing whatever it wants, right?
Precisely. So we'll have to break this down.
Yeah.
So let's start with the first thing. Is agent just a function? Let's start there. Yeah. So yes, in essence, the implementation of a function, the implementation of an agent is just a function. All right. However, in your code, it's not just a function. It's going to be an object. Why? Because you might want to track how many times did you call the LLM. You might want to track costs. So there's some bookkeeping which needs to be done around it. So in your code, it's going to feel like an object, but the body, the meat, the essence of it is going to be a function. Yeah. Right? So just trying to be clear on that. Yeah. Now that we've figured that out, that okay, there's going to be an agent.run, which you pass in an argument and it gives you back an answer like a function. And internally it calls a reasoning loop, which is just another function. The question is, how complex that function could be, right? Is that function just calling one prompt and getting it done? Is it calling multiple prompts and getting it done? What if you do not even know how the reasoning loop should be structured? What if you want an agent to be able to figure out the best way to solve it.
Right.
So you're planning you're letting the agent plan its own execution. Now, how would a software engineer try to do this? Can I go back to React as an example, front-end engineering?
Yeah, sure.
In front-end, we have components, right? Whenever we're making a big fat app, again, I need to stop saying fat, but whenever we're trying to make an app, right? We don't just make it as one big HTML blob. We make tiny components, like button is a component, which encapsulate the state of just a button. And then you compose.
Right.
You build a page out of smaller widgets. Those widgets will have more primitive things like buttons, right? Why can't we do the same with agents? Why can't we just have an agent which does planning? That's it. It just gives us a plan. We have one agent which takes the plan and runs a loop, right? That for each item in the plan list, I'm going to run another agent. And you start composing them together.
Right.
Now you'll get to a point where you're like, oh my God, the ifs and the for loops and all that crazy stuff is very hard for me to code out. Or you'll get to a point that, wait a minute, if this agent dies in the middle, I have to run the entire thing again. Now you're getting into territory where you need some reliability in the workflow. Not in the agents. The agents are doing their job. You have one big agent calling tiny agent in its loop, right? One big agent calling tiny agents in its function. But eventually you'll be like, okay, I need to wait for a human to give me an input. So now your agent needs to pause, wait for a human to verify things, and then continue. Now these are workflow problems, nothing to do with AI. Okay? Let's go back in the engineering space and see how the world has solved workflow problems. State machine to the rescue. Because state machines, like I said, it replays, right? It captures every state, which means if I have one agent which modifies a state, the other agent modifies a state, and then we pause the entire execution. Let the human verify the final state, right? Like the output of the plan or whatever. And then you resume it. So all the DAG and stuff is just a call within the function. So your master agent or the topmost agent is calling out a workflow as a function call, as you wouldn't do it normally, right?
Yeah.
And that DAG is going to be calling other agents internally. So again, for the end user, it's just calling a function at the end of the day. It's just agent.run. But it happens to be that the agent.run's function implementation is calling a DAG under the hood. Make sense?
I never thought about this in this context before, but would you say then potentially the agent.run function is analogous to the render function in React?
Precisely. That's precisely what it is. That's very good because you can render individual components. You can render a page.
Yeah.
The point is it's composed, and that's why you need an abstraction. Without an abstraction, it's not possible to do composability, right? You can only compose if there's a fixed way to pass props. Or a fixed way to render a component, right? And that's what an agent is. It's just a function with a class on top so that it gives you a fixed interface to interact with it. Now, whether it's calling a DAG under the hood, whether it's calling LangGraph under the hood, whether it's calling another agent under the hood, does it really matter?
Not really.
To the consumer.
To the consumer, none of it matters,
Exactly.
to be honest. Like, it's only are they getting the result they want to get, right?
Yep. So that's the reason why I don't want to put a scope to the agent. Let the agent concept be fluid. The spirit of the agent is try to do something reliably, right? Try to do something with non-deterministic rules reliably, right? The non-deterministic or indeterministic part is the keyword here. Now, whether you call other agents, whether you call LLM prompts, however you do it, it depends on the layer of the agent, right? If it's the primitive layer, is it a widget layer or is it the page layer, right? It really depends. The complexity of the agent, I'll let it be fluid for now because we still haven't seen a strong patterns which we can say that, okay, these are the 3 or these are the 4 patterns you're going to see through and through. I don't think we're there yet.
No, I don't think so. And I mean, we can speak to some of these patterns, maybe briefly, right? Like, I mean, you can see student teacher, some of these patterns we've seen in other nature that show up like small primitives that you see. But hasn't been like a big thing, and we're probably just gravitating towards what works. But what are some of the small patterns you find that are working for people who might want to be starting out?
You know what? I just had a conversation with somebody on this yesterday, and I was asked the same frigging question. And one of the most common patterns in the agent space is the React pattern, right?
Yeah.
Where you have like a reasoning LLM and then you call a tool and then you go back to the LLM and see, do you need to call another tool? And then you keep doing that as a loop.
Actually, that's part of what made LangChain popular right away, because LangChain had their own React style agents. They were the first ones to kind of have it popularized, right? And that was like took the brain. Yeah, but go on.
Pydantic AI works with React by default. Like that's the only way you can use it. In fact, there's a GitHub issue to stop it. Right? So, I mean, sure. But the thing is, even in those patterns, there are nuances. For example, you get a tool call. Now, do you want to give the tool call's result directly to the LLM? Or do you only want to see that if there was an exception, I want to go back to the LLM? Like, there are some nuances here. What is part of the conversation history? Do you give the LLM the entire conversation history of every tool call yet? Or just give it the last one? Or just, do some kind of RAG step to enrich it to make it even better? How do you decide all of these things? The point is, there are so many nuances, even in standard patterns, that I find it really hard to encapsulate them. Yeah. And that's the reason why in one of my streams, I created this NOPE agents to demonstrate that, okay, sure, you can have some patterns, but at the end of the day, you'll have to let the user implement their own function body, because you cannot standardize these things just yet. There are so many nuances to making LLMs work the way you want.
Yeah, that was my comment actually on the stream. If you remember, it was like, are you breaking the abstraction? Like, how strongly held should that abstraction be?
Exactly.
And, I mean, like, it's up to the user at the end of the day, right? It's up to the user and the business logic, but that ends up being what. Now you touched on it there, so that's why I want to go into it. But you mentioned RAG, right?
RAG.
Last year, RAG was the rage. Everything was.
It still is.
Well, now we're seeing RAG in production, right? So, like last year, I think everyone was kind of learning about RAG.
Right.
But then I see all these posts all the time on LinkedIn or Twitter saying RAG is dead, right? I don't get it. So maybe you can shed light on it. Why are people saying RAG is dead? And I'll tell you the context they're saying it.
Okay.
No pun intended. They're saying, okay, context windows are going to be like millions and billions of lines, and RAG will be dead because you can just throw everything in the context window, right? I think that's where they're coming from, right? So your perspective on that. Is RAG dead, Noorain?
Oh my God. Again, I'm an engineer who wants to get stuff done. And in engineering, you think about the cost and you think about the feasibility. Sure, the context is getting better. And I mean, Google is kind of leading this, right? But how expensive does it get? Right? Our LLMs, there was a recent study which came out. I can't quote the paper because I don't remember which one. But it claimed that the needle in a haystack, that's what they call it?
Yeah.
It's not accurate.
The DeepSeek paper, the latest DeepSeek paper, I think.
So the paper I'm talking about claimed that needle in a haystack is not a good metric, because whenever you're doing RAG, you're not doing a needle in a haystack. You're doing multiple needles and you're seeing how they relate to each other and filling an answer. And what we learned, that even though big context can give you needle in a haystack, can they reason on it? Because it's not just one needle, remember. A RAG has to figure out the right chunks in a very broken way. There's a lot of reasoning going on in getting a in-context learning answer right? And what the paper claims is the performance doesn't scale with the token size. So a lot of these headlines could be clickbaity. And we've always had clickbait.
They definitely are.
Yeah, definitely are. Absolutely. But RAG as a concept has to be there, because as RAG starts getting more popular, our data or knowledge bases, should I call them knowledge bases, they're going to expand.
Right. Yeah.
And the knowledge, it will keep expanding. And to get the best quality answer, you will only want to give relevant information to your LLM, right? So there's always going to be some retrieval logic to filter it down, not just to save context size, right? But also to improve the quality of the context given. Right. So that you get a better answer. Because LLMs, you never know, the training data set has because of the way it's trained, it may pay attention to one particular line which it got from one chunk, which is really random, and you just get a weird answer now. You never know, man. You never know. So I think RAG, even if we solve the context problem, which I don't think we have, RAG is just going to be important because the quality matters as much as the quantity.
I don't think the context problem can ever be solved fully, right? You can never, infinite context window is not feasible. Is there an analogy to this though, in from either systems or from software engineering or anything you can think of, where like an analogy
Absolutely.
for RAG that you can think of?
So it's not a perfect one, all right? But this is how I like to think of it. Earlier databases were single node. right? Like Postgres or whatever. Like, I don't know what they use. Oh yeah, Oracle. Oh, don't use Oracle. But no. I mean, if Oracle wants to sponsor me, then sure. Sponsor us? Sure. Yeah.
Sure.
Okay. Wait. So we had single node databases. Then we had the NoSQL realm, where we were like, oh, you know what? We can shard and scale. And then people like, oh, dump everything. And they forgot about data models completely. And they realized that their query performance doesn't scale with the size of data. Sure, you can store it. But just because you can store it on multiple nodes doesn't mean you can scale the query, right? And now we are seeing this new SQL breed of databases. So the point is, once we solve one problem, which was the storage problem, like we wanted to increase the volume of storage, we introduced a new problem, which was query performance.
Right.
Because querying, like the scatter-gather pattern, which Mongo and Elasticsearch started using in the early days, that was a disaster. So I think it's not the same, but it's going to be similar in the rack space. Sure, you can shove a lot of context in there, but the quality will start becoming a problem. Like, can the LLM even reason through it, right? And I think we'll have to see that in practice. Because the benchmarks, I don't know about benchmarks, but we'll have to see anecdotal and evidences as well to see if the LLM can indeed reason across everything. And needle in a haystack doesn't convince me.
Yeah, fair enough. So, okay, now that we kind of touched on, right, let's go back to agents again for a second. We talked about agent patterns, right? Now, the big concern about everything LLM is reliability, right? Like, we have a couple of things we are working on actually in-house that we can't really productionize yet because agents are not as reliable, right? Now, there's one thing we've recently discovered, and I don't mind shouting out the tool BAML, because that makes not just agents, but working with LLMs more reliable. Now, I'll give you a little bit of context, right? So BAML, I've actually been using BAML for a little while. So I met Vaibhav like late last year. He's a great guy, by the way. Like he spent like an hour just to go into my code, debug it. At that time, like I was setting up Olama. So we were setting up Olama provider on my machine remotely. He helped me out. And we met in Seattle. Great dude. Like I think the whole engineering team is cracked. Those guys are going to do well, I think. The developer experience they've created is amazing around it. But there's something about this that makes this experience very delightful and makes it so that LLMs might be reliable. Now, I know you've done a lot of work on this and stuff.
Yeah.
But how is this potentially a solution to the reliability issue?
Right. So, I mean, whoever doesn't know BAML, guys, check it out. I'm ready to put my entire weight behind it. It's so freaking good. But going back to what BAML is, or where does it fit in this entire agent space? I think the answer to that is that in your agents, there's a lot of business logic, like checking whether the SQL query was right or not, and actually talking to the LLM, right? BAML is trying to solve the problem of talking to the LLM. So it's not an agent tool. It's a building block which you can use to build agents on top of, right? That's what BAML tries to be. Now, how is BAML trying to solve the reliability problem? Well, how should I put this? So BAML essentially, it shines when it's trying to do structured responses, right?
That's what I started using it too.
I think that is the one use case which it really shines in. If you just have a string response, then BAML might just be an overkill. But I think the experience is good enough that you would still use it. But the main reason for using BAML is definitely structured responses. Now, most of the agent tooling out there, including LangChain, Pydantic AI, again, Pydantic AI, good tool, but still, the way they think about it is, hey, we'll ask the LLM to give an answer back in JSON, and then we'll validate if the JSON is right or not, and that's pretty much it. Is that the best way to do this? Like, think about the problem. Like, if we go deeper into the problem, what if the JSON is malformed? And not everything can be described in JSON. For example, what if you want to generate some code, right? But generating code in JSON would require the entire code to be in a single line. That's not feasible. How do you do that? Moreover, let's say you're building a RAG app with citations, right? So you want to print out your entire what do we call it? The response out on your chatbot or wherever, but you want to make sure you reliably show the citations as well. Of course, you can rely on the model to, insert that links in the markdown and, do the citations for you. But is that the best way to do this? Is this reliable? Probably not. So what I'm trying to say is we need to go deeper into the way LLMs best response. So like code, they like to write it in multi-lines because we like to write it in multi-lines, right? Citations, it's better to write it as a JSON array, right? And have a text blob, and the JSON array has references to the text blob. And your front end handles the citations part or making it links. Okay. That's a more reliable way to do it. That's easier to test way to do it because now you can actually, let's take the citations example. Okay. Whenever you're doing a RAG app, you have a text response, you show it on screen. One, you can rely on the LLM to put the links directly in the response, but it might screw up. Now, a better way to do it would be, hey, LLM, you create the entire text blob for me and give me an array of objects. Each object will be a sentence along with a link, right? My front-end code will find that sentence in that big text blob and insert a link for it.
Right.
Now, this is way more testable because now what you can do is you can write a test saying that, first of all, are all the citations actually a part of the main response? Next, are all the citations actually valid? Are they pointing to the right links?
Yeah.
Are these the citations you expect? Like, for example, for your test cases, you want to make sure that your RAG application always cites 3 examples because those are the most important ones for a given question. But if you just had the text blob, writing those tests would be like crazy hard. But now, since you have a JSON array, it's so much easier to test these things out. So what I'm trying to say is, by deepening into the structure response space and by not enforcing the hard limits of JSON onto the model and being a little bit loose with it, you are able to achieve a lot more. So the biggest point of BAML is not that it's helping you write tests. It's shifting the way you work with LLMs in the first place to make the code more testable. Right? Like the entire philosophy that TDD is great, like test-driven development is great in engineering. Why? Because it forces you to write functions which can be testable, right? So changing the way you write code can help with making it more reliable. That's the entire philosophy TDD is based on. BAML is kind of trying to do something similar here. So it's not just that, oh, BAML will magically make your code more reliable. It doesn't work that way. It just changes the way you do things to make testing a lot more easier and a lot more intuitive for an engineer. That's the beauty.
And just even actually their playground to test it is amazing, right? You click a button. I don't want to run my code to test, right? I want to test the prompt out.
Yeah.
And I know they actually have some other stuff coming that, that'll help make this easier.
Yeah.
Maybe by the time this is up, they'll have that announced.
Yeah.
But the other thing, I think it forces you to think about that abstraction. We talked about that abstraction earlier, but at its core, it can be just the prompt, right? You can just be at the prompt layer, single prompt.
Yeah.
Let's make that prompt have a structured output.
Yeah.
Use the output of that.
Yeah.
And that's all BAML does, right?
Yeah.
Even then, that makes a lot of smaller models a lot more reliable. Yeah. But then you could actually abstract it more, right? There's like, you can have fallbacks and, different decorators and there's a lot of other stuff under the hood.
Yeah.
What's something that you personally used using BAML that you thought, oh my God, this is crazy. Like this is like way different than how you used to do it, and this just makes my life easier or makes this small model, dumb model way better?
So actually, I already hinted at it, but one is the way you look at prompts. So the thought process, I think that's the biggest hit for me. Of course, there's a lot of engineering marvels they're doing under the hood as well. We can talk about it. But I think the biggest one for me is your prompt is just a function. In BAML, for folks who don't know this already, in BAML, you write a prompt as a function. You literally define your types, and you can say my function takes an argument and it returns an argument. And the argument is not just string. It's literally that type. And that's a hint to the BAML parser, which works under the hood, to coerce the LLM's output in the right types. So whenever you interact with the model, you interact it through functions in your language, so they generate the entire client stuff for you. And you don't have to worry about type safety anymore because it's just taken care of, right? And of course, it does a lot more under the hood. One of the things it does under the hood, which I really love, is it's not strict about JSON, right? A lot of the other tools, Pydantic AI, anything, Instructor, they all use JSON in a very strict mode. One big problem with JSON is strings can only be single line. There are no comments in JSON, right? But if you want to generate code or if you want to do the RAG application I just spoke about, it's easier to let the model use multi-line JSON or multi-line strings and allow it to insert it into JSON. So you still want structured output, but you still want the leeway to do multi-line strings. So JSON breaks here. BAML's parser is smart enough, or let's say forgiving enough, that it's go like, hey, model, okay, sure. You try to use backticks to make a multi-line code response or a multi-line string response within a field in JSON, which is not allowed. But you know what? I'm gonna accept that. And it magically gives you the perfect JSON output for yourself. So it's allowing the LLM do things in a way which is more intuitive for the model because it aligns better with its training data, and not and it's eliminating the need for you to worry about extracting the right data from it. Like another example would be chain of thought. In chain of thought, you let the model think before you actually get the JSON output, right? And thinking gives you a way better answer, especially when you're talking about open source and open weight models, which I kind of use a lot. So you would have to like figure out that, okay, where's the JSON in all of this? What if it was two JSON? What if the explanation or the reasoning process has some JSON bits as well? How do you get the best answer possible? That's a lot of logic to write. I mean, people don't think about it. Like chain of thought could have a lot of crazy braces going around and your JSON parser would break. BAML takes care of those things. But by far my favorite feature, and I know this answer is going long and you're itching to add the next one, is semantic streaming. And I know you love that one as well.
Dude, I didn't know about this until your stream. And it's awesome, right? Like, because before this, I was streaming, I would wait for things to stream. I would even change the way my code is written for the experience of that streaming. Because I would do it like YAML, for example, because now I know YAML, I can stream portions at a time. Now, just being able to semantically stream and only stream a citation when it's done, it makes RAG look way better on the front end.
Much better.
That experience is,
For the viewers, semantic streaming is BAML's concept that you have a big JSON object, let's say with arrays and stuff like that. Now, waiting for the LLM to, finish the entire thing would just take so much time. So everybody else just shows a loader because, I mean, you can't parse JSON till it's done. But BAML allows you to parse JSON and spit out events that, okay, this part is done now, this part is done. So it's incrementally parsing that JSON, which allows you to do crazy stuff on the front end.
Now, there are other things that people have done, like partial streaming. Like the models will stream the JSON so you can start streaming it. And, Pydantic does some stuff
Pydantic has done some
stuff here. But the way you can just define the individual components of the semantic streaming, that was like mind-blowing for me. And I was using it already, but I wasn't using that feature. That was crazy.
Semantic streaming along with the forgiving BAML parser is the best combination. Right? You can have chain of thought, you could have multi-line strings, you can have semantic streaming, and it just works. Oh my God, it's amazing.
Yeah, it's awesome. So moving on from BAML, and BAML is great, definitely check it out. Something's been recently hot right now, MCP.
Ooh.
So first of all, maybe give a brief definition of what you think, your definition of MCP. I know you've gone deep into it, right? So you'll be able to give a better definition than I can, and also your thoughts on it and how that might change things.
That's a loaded question. You want to break that down for me?
Let's go. First part, for the viewers, what is MCP?
MCP is a protocol to make LLM applications and tools talk to each other. Actually, it needs to be more generic. I should think of a better definition. It's essentially allowing, I should even say LLM. MCP is a protocol to make clients and servers talk to each other. That's such a lame definition, but that's exactly what it is, right? But let me take an example. GraphQL. Like GraphQL was amazing because it's self-documenting, right? You can look at the GraphQL schema and know exactly what the capabilities of the server is. You know exactly how to talk to that server, and you just use it, right? And it just works, right? Of course, there are some cons of GraphQL, sure, but that's amazing. Or if you come from the REST world, there's Swagger. Swagger,
Which is Open API spec.
Open API spec, pretty much, The Open API spec. No, it was.
We're good, right? Yeah. Keep going.
Let me
Open API spec.
The open. So Swagger is essentially the Open API spec, and the idea is like you document your API so that others get a contract to consume it, right? So essentially, that's a way clients can talk to the server, essentially. But the problem here is, let's say Ashaya, you have a company, and you are a company with a product, and you have a documentation site, right? And let's say I'm a chatbot provider. I'm a chatbot for documentation. So your company would want to use my services to get a chatbot-like experience for your documentation. Sure, right? Now, the thing is, how do I digest your documentation and your knowledge base? Because documentation is not textual. You could have a lot of things under the hood. You could have PDFs, everything, right? I could make my heavy duty RAG system, but I'm sure you guys would have your own RAG systems, right? To use that to build applications and stuff like that as well. Now, you would publish your own Open API spec or GraphQL spec, which I'll have to integrate, which means I'll have to do some work. For every customer I onboard, I would have to integrate with their RAG APIs. Does that make sense?
Yeah.
Because company A would have a different spec, company B would have a different spec. What if there was a way in which I just get your URL, like the place your API is hosted, and my models can auto-learn the tools available for me to use? Like auto-discover. Like I know exactly what you're capable of. Like I can look at your RAG pipeline and say that you have a search vector function. And I can say that, oh, there's another search graph function. There's a generate code function. And these are the 3 different tools I can use. And my chatbot auto-configures itself to say that based on the question, I'll call the right tool. MCP does that. MCP is a standard product. It's like its own Open API spec. It's like its own GraphQL spec with its discovery endpoints, which allows a client or a platform like me who's trying to create, I'm not trying to do that, but who's trying to create a chatbot for documentation, but it's allowing me to integrate with the RAG pipelines or the different APIs other people have without having to write any integration code. Does this have anything to do with LLMs or AI? Not really. It's nothing to do with LLMs. But LLMs benefit a lot from this because LLMs are indeterministic creatures which can decide what tool to call. Which means if you expose the tool set to an LLM, it's smart enough to figure out when to call it, when not to call it.
Yeah.
Which makes MCP so powerful for the LLM age. That's the real thing which people should be talking about MCP, that it allows you to discover tools on servers dynamically without having to write any code. But I think that's like the missed part of MCP. And I think that's the craziest thing MCP has to offer.
People are kind of like stressing about, in a good way, about the unified schema thing, but as a replacement, that's what it enables, right?
Exactly.
And I think people aren't talking about that enough. Like, what does that actually enable?
The unified schema is what enables this auto discovery and auto integration. But the auto integration is the fun part. Right? Now we are exposing an ecosystem where a lot of people can create their own RAG pipelines, their own tool sets, and just expose it as an API. And as an engineer, I don't have to go through their docs to integrate them. I just point to their MCP server. And of course, provided I have some binding code for MCP, I can get my LLM to have those capabilities without doing a lot of work. So I just do the engineering effort for one such tool. And all of a sudden, I have access to all the MCP compatible servers on the planet. That's mind-blowing. That's the power of MCP.
Yeah. It's gonna be interesting what people do with it.
Absolutely.
The other side of it though is LLMs are getting better and better at traversing the web, right? So UIs in general, right?
Sure.
So there's another school of thought that says, why do we need APIs? Why do we need MCP? Let's put performance aside. If there's a UI, if there's any action on the web I want to take, my LLM can just go and take it. Like, I can have an agent just go there, browse something and do it, right? So how do you kind of balance those two things out?
I think this...
And don't talk about performance, because obviously an API calls will be faster, MCP will be faster, regardless of that, right? So let's assume that the latency is not an issue.
Okay, keeping latency aside, I think this is a question which came up a lot in my community, especially when the OpenAI operator came out. I think that, of course, we had this concept with the rabbit.
Yeah.
Yeah, the rabbit. So that's the idea, right? Yeah. Forget the companies. The concept is operators which can, you have web agents, and the LLM can see the website and take actions. Always remember that we are software engineers at the end of the day who are trying to build applications, and we want applications which work all the freaking time. So, and we all know LLMs are very sensitive to prompts. And what we are suggesting here is to use the HTML of a web page or the rendered web page as the prompt, right? Yeah. And it works. And of course, you might have to do some tweaking to say that, okay, focus on these IDs more. Like maybe, you want to focus on one. There are two buttons which call submit on a page because one submit is hidden behind a form, but one submit is literally on the page. Because, HTML is weird that way, right? Now, you might do some weird trickery to make the LLM go like, okay, focus on this submit rather than that submit. It's not that easy as just give it a page and it's going to work, right? But what if the website changes its web page? Will the prompt still work? How do we know that? Is there versioning for websites? So how do you make this reliable? The entire point of versioning and Git came about because now you can write tests against the specific versions. API has versioning, very strong versioning. Websites don't have that, and they'll never have that, right? So my biggest question about the operator framework is it reliable enough to be generic? And in my opinion, LLMs are not generic. Your prompts have to be tailored or slightly customized to nudge the model into the right answer based on the prompt. And websites, just because the way I build websites is going to be so different than how you build websites, it's gonna mean that I'll have to create some agent for let's say an Uber website, another agent for Amazon website, right? And if they change their website or they change their IDs or the way their buttons are, the prompt might break. APIs are a more reliable way to do it. Now, the biggest problem and the reason I think the web was being focused so much is because the effort of integrating with all these APIs is so exhausting, right? Especially the way LangChain does it. They have somebody would have to create a LangChain wrapper and you would have to modify your code to include that library and import that wrapper. That's so much work. Yeah. Every new tool you want to support, it's like a new wrapper you have to import and just your code gets bloated. Nobody likes it. MCP is trying to solve that problem. MCP is saying that, hey, you integrated once and then you have access to all the tools in the planner which implement it, which solves that integration hurdle. So I think scrapping the web is an intermediate solution till we have more and more people implementing a protocol like MCP. Once the world jumps into the MCP bandwagon, and I'm not saying MCP is the answer to everything, I'm saying it's the first best attempt to get attention by a big backer, right? Which matters.
Right, yeah. That matters a lot.
That matters. Yeah. So it's a big backer trying to push something, and a lot of bigger players have started adopting it, which means it's going to standardize. Hopefully it does. Maybe we get something better. Maybe they create a version 2 of the protocol. That's obviously that might happen. But the point is still MCP matures in its ecosystem. Web is a hack, which works for now. But once people move to MCP, why would you deal with the unreliability of the web? That just doesn't make sense.
That makes sense. Shifting gears a little bit. So obviously LLMs are enabling a lot of things. And one of them is code generation.
Oh my God.
It's so good at code generation. I know you did recently a stream on Cursor.
I did.
And so you've shifted completely, right? You've been using Cursor now.
Yeah.
So how do you think the developer, I guess the day in and day out of a developer shifts with all these tools? And because LLMs are really, really good at code gen, really good at code gen.
Yeah.
Right.
Yeah.
So how have you been using it, and how do you think this changes, what we do on a daily basis? It's definitely changed my job.
So I did a very evil thing when I learned the power of Cursor. So I had like an intern working with me, and I told her, you know what? If this Cursor thing is really as good as it seems in first impressions, I might not have a job for you.
That's brutal.
I know. I mean, I'm just kidding. Of course, I'm just kidding. But that's the truth.
Yeah.
Right. The thing is, Cursor is like a junior dev with senior dev powers. That's how I like to define it. Like, you talk to Cursor as if you're talking to a fresher or a junior dev. Like, you explain out your plan. Like, hey, this is an issue I need you to do. This is how you do it. These are some things you need to keep in mind. Stuff like that, right? But the code Cursor outputs is the quality of a senior dev. So I don't have to spend so much time in reviewing and things like that. Right. I know that if I've explained my logic right, it's going to figure out what files to touch and what exactly to modify. Now, for a senior engineer who has designed or architected several applications, explaining what to do is the easy part, right? Yeah. But writing code is the hard part, because explaining requires a different context, like a different way you think, and writing code requires a different context. And a senior engineer is more involved, or rather me as an engineer was more involved in working with different people to tell them, okay, this needs to be done. This is how we're going to model the solution. And writing code was a chore, right? Now I don't need to do that anymore. Now I can be like, oh, I can think about solutions and I can just go to Cursor and make Cursor do it. And we'll do it in like a few minutes. I can review it. I can prompt it again. It's like a pair programmer and just writes the stuff for me. Now, I'm not saying it can completely replace everybody on the planet because even I have limited time, right? But for me, Cursor is going to widen the gap between junior and senior devs. It's going to make senior devs like OP. They're going to be able to do a lot more. But for people who think coding is a craft, they are going to lose out on a lot. So we're going to see more generic code. We're going to see more, bland code, whatever that means. But we're going to get more stuff done.
Right. Yeah.
That's how I look at it.
Yeah. No, that makes sense. And I think one discussion I had recently is, do you think that these tools make the way you design services a little bit different? So as in, would you tend to have, like, say, a microservice architecture just because Cursor is going to understand the context here because it's not that big. This is a defined block of code. So I know maintaining it will be easier now because it's not, because we used to do microservices for maintainability by humans. Yeah. But now maybe we need to shift to microservices for maintainability for agents.
Yeah.
Because I know you come from the DevOps world. I really wanted to ask you this actually.
I really hope that Cursor doesn't enable such decisions. Cursor is not a means to do things you couldn't have done before in terms of complexity, right? It's still AI. You still have to own the final responsibility, right? So microservices is a mindset, and the mindset is that each team has its own service. But if you're just creating microservices now because it's easier, you're just throwing in different languages because it's easier, that is going to bite you back eventually. Because what if you have a problem in production? If you don't really understand the ins and out of that language or that framework that you adopted, you're going to be in a bit of a pickle, right? So just because code is easier to write doesn't mean it's easier to maintain. Because maintenance is not just in terms of maintaining the code, it's also maintaining the final output, the deployments, the CI pipeline, the CD pipeline. So much that goes to it. So for me, I think right now, from the capabilities I've seen with Cursor, which is amazing, like literally, like sometimes I'm like, it's easier to talk to Cursor than a dev because it just does things. But I would still say that, okay, I wouldn't make Cursor do anything unless I could have done it myself or my team could have done it themselves. So it's just it's a productivity boost, but not a complexity unlock. Yeah. Not yet. Okay. Not yet.
Yeah. But it could be.
So I'll be honest. When I was making that NOPE agents, TypeScript type system can sometimes be overwhelming. Yeah. I had a type system problem, which I still don't know how to do it. And then I was like, Cursor 3.5, can you do it? Did not do it. 3.7, can you do it? And it freaking did it in one shot.
Right, yeah. Sonnet 3.7.
Sonnet. My bad. Sonnet 3.7 did it in one shot. And I was like, holy crap. It unlocked something I couldn't have done before. But that's the part of the code base I'm most scared to touch now.
Interesting.
So, because it's so brittle.
That's actually interesting. I had an experience like this the other day. So, one of my good friends, he challenged me to go a day without any AI assistance when I'm coding, right?
How was that?
This is actually Thursday or Friday we did this, right? It was kind of frustrating because I realized how less productive it made me. Yeah. But it was actually interesting in a couple of ways because when I was doing it, I was thinking about how I would have done it otherwise. And I'll give you a good example. I had to write a couple of complex SQL queries, right? So first of all, I usually go text to SQL. I would have probably just prompted it, hey, write me this query. Then I would have double checked the query, make sure it runs, test it, do it in my testing environment, run it. Okay, good, right? And then I would have moved on. Yeah. In this case, I was actually writing all the subqueries, testing the subqueries, making sure that the subqueries are optimal in terms of latency, adjusting them, and then coming up with a final prompt, right? And so when we prompt, we might have to prompt in a way that actually enables that, or give it access. I need to give it access to the cardinality of my data sets, my indices, everything. And usually you don't do this. You just give it maybe the schema, that's it. And you tell it to give it the query, right? So that's one example. So when you don't have it, I feel like it makes you more mindful of the things you need to follow. So we do some blind decisions, which is risky. Yeah. But then on the flip side, I only got three tasks done that day when on a normal day of, these are like
Precisely.
2 hour tasks, I'd say.
Precisely.
So 3 hour tasks, I would have gotten them done by noon for sure.
Precisely.
So,
and that's why I mentioned that Cursor is going to make senior engineers OP, because senior engineers review a lot of code anyways, right? So if you generate a SQL query and it comes to my desk, and I would really make sure that the performance of that query is intact or within the guidelines, right? I'm sure you would do that as well, right? Now, those are things which mid or junior devs probably won't do. So they would just rely, I got a SQL query out, so I'm just going to use it, right? But like you said, if you're writing it yourself, you're going to be more mindful of these things from scratch.
Yes. Yeah.
But once you get to a point where you reviewed enough code of other people, you're doing that anyways, right? Like the art of reviewing, you kind of construct the same thing in your head, like how would I do it? And see if this kind of aligns with how I would do it. That's how people review in the first place, right? And I think Cursor is really good because it allows you to do that review while it's generating all its answers. So you don't have to accept its code suggestions until you're absolutely sure, but you can still run it.
Right. Yeah.
That unlocks something in my brain, right? So, but I think coming back to the point, I wouldn't use Cursor to unlock new complexities. I would do it for things I can still review, right? Which is still something I could have done. I know I would have taken 3 days to do it. Cursor will do it in like 5 minutes.
Yeah.
But that's a productivity boost Cursor gives you. If you try to now get into a sphere like, okay, you know what? I want to build a RAG pipeline, but I've been doing it in Python, but I think Rust is the best language on the planet right now. Of course it is. So let's make Cursor write Rust code. And it can do it. But should you do it?
Are you going to maintain Rust code if you're not a Rust developer, right?
Exactly. Yeah. Exactly. What if Cursor gets stuck someday and now you need to figure it out yourself?
Debugging Rust. Good luck, right?
Oh my God.
So this is, I wanted to ask you one thing, because this is probably the most common question that I get asked, as a founder and as someone in tech who's a CTO, is from junior developers, right? Right now, the market is a little bit rough and they want a job, right? And they're like, or they want to get into GenAI. And they're like, how do I do it? Or how do I do a project, right?
Yeah.
Now, you had a great video, I think, which was like a roadmap of GenAI or roadmap to RAG. So by the way, check out Noorain's channel, right? So Noorain, while we're at this question, why don't you tell people a little bit about your channel, what it is and how it came to be actually, and then we'll go back into the question.
So I realized that I love engineering, right? I love solving problems, but I love, like in my interaction with my team and things like that, I realized that I love explaining and teaching things more than anything else. So something which helps me combine those two, right? To solve problems and teach how I solved it. I think that was the start of the YouTube channel. I mean, technically it started because, I had a startup of an open source company. So you need to kind of create content, and it started that way. But then I quickly realized that, oh, wait a minute. I think I enjoy this. I really enjoy this. So the YouTube channel was pretty much dead for the last 2 years. Restarted it a couple of months back.
YourTechBudCodes, by the way.
YourTechBudCodes. Thank you so much. The idea of the channel is very simple. There's a lot of hype going around. But we need to, at the end of the day, we need to build stuff. That's what the channel and the community is about. You want to build stuff, so do these tools help you solve real problems? The channel is a place where we look at it we look at a tool, we dissect it, we put it under the lens, and we figure out what's the engineering behind it and how can you use it. And you form your opinion. I will share my opinion for sure. But the goal is to make sure that you have enough information so that you can start forming your own opinions. So it's a channel not for AI enthusiasts. Of course, AI enthusiasts would watch it as well. I know a lot of them do. But it's mostly for people looking to build with AI. And they're serious about, building real things. That's the intention and goal with all the interviews or all the tools that I review and cover.
And you're building a great community too, right? Like I'm getting a lot of value out of it too, right? Whenever I can't always pop into your stream, but whenever I do, right, I always learn something. When I'm on the stream, or the Discord channel is awesome too, right? You have so many great minds in there. You have a builders hour. You have some other stuff there too, right?
It turns out a lot of people are trying to build with AI, and there's a lot of really cracked engineering minds working on several problem statements, which a lot of people could benefit from. And what I realized was my streams, which I started doing, my YouTube channel is mostly streams and videos. It's one-sided. So it's almost like I'm sitting in an echo chamber and I'm echoing out. And the comments I get on my stream, which are amazing, by the way, like my chat is amazing. It's very restricted form of of information for me to upgrade myself. Right? How do I get feedback whether what I'm saying is actually valid or not? What if there's a counterpoint? So the entire idea was, okay, there's a lot of really smart people asking really smart questions. And to the point where I'm like, hey, you know what? I need to learn more to answer. So what if these smart people could get on a call and every time they take turns on, okay, I have something to present, I have something to present, and we all either grill the hell out of each other, learn from each other, or do something like that. So I wanted to build this meetup, a virtual meetup, where the best engineering minds can come together and talk about problems they're passionate about. I think there's a lot of value in just listening to such conversations, but the ability to participate in them is even better. As a presenter, for your confidence, for validating your ideas, and as a listener to learn new perspectives. And the community was born around that way, right? So it was a means for me to get insights from my community, which I was building through the YouTube channel, and see if I can give them a platform to talk about their ideas to the same audience and also on my streams. So that's how the community came about. And I think a lot of the engineering folks in the stream, they just loved it. And I think the channel for a lot of them has become a go-to place where they see something new, they just dump it in the Discord channel, and they're like, "Hey, give me your thoughts on this." And now that kickstarts a conversation. And for a lot of them, like even when it comes to BAML, BAML is often not the first place they go to. They actually put their revelations and stuff on the YourTechBud Studio Discord.
Oh, interesting.
Instead of the BAML, and then we have to go like, wait, I think they should go on the BAML as well.
Right, yeah.
So of course, questions and all of those things are in BAML, but the possibilities, like, oh my God, can we do this? Oh, I just did this. I just used this model. I used 5.4. You know what? The vision model is as good as GPT-4.
5.4 apparently is really good as a segue.
Really good. Yeah, it is really good. I mean, the Discord is a place for such conversations. Where we're fascinated by cool things, but then we want to dive into the engineering aspect because it has to be productive and useful to the builder. Otherwise, what's the point? And yeah, by the way, on the community, on the Discord, we have a bi-weekly builders meet, which is the said meetup. It happens every Saturday morning. No, every other Saturday morning at 8:30 Pacific. And I would love to see people there, and especially if you want to talk about something.
Yeah. Yeah, for sure.
Ping me.
So given that, right, given that you have this community, a lot of developers who have, so going back to the question of like someone, a junior developer wants to get a job, wants to get into AI, obviously watch your RAG video, maybe that might be one of the things, but how could they, what advice would you give them to get into the GenAI space or start building with GenAI? And the easy answer is, okay, just start building stuff yourself. Yeah, well, that's, of course, we can give that answer, but a more systemic way of them.
So So I started a company when I was doing my undergrad, like in my third year engineering, second year engineering. So I started a company in my second year engineering. So that forced me to think about things in a different way. Now, again, that startup wouldn't be called successful in the traditional terms, but I did end up getting a really good job, which transferred me to Canada, and it's very secure and blah, blah, blah. It's going really good. Is that one way to get a job? Probably. But the idea which I try to propagate to people is, you need to stop thinking about, okay, I need a job, so I need to learn this. I need to do this. You need to start thinking about, okay, they need to solve this. The company I'm looking for, they need RAG. They need graph and RAGs. Start thinking in terms of the other person rather than yourself. Now, it's going to be very hard for juniors or undergrads to do that. Get a freaking mentor. Right? Get a mentor. So I've been trying to mentor some people in Vancouver as well, like in our city. And the suggestion I give them is, see, job hunt is going to be a struggle and you have to do what you have to do. Spend like an hour or 2 hours every day for your interviews, for your applications and stuff like that. But also spend an hour or two working with a mentor, not on projects you're building by yourself, unless you have like a really good idea, but rather working with a startup, working in an open source project, working in the community, working in open, and in a guided way so that you're not wasting your time doing unnecessary stuff, and have incremental progress checks and run it across in your interviews. Like in your interview, just drop by that. Oh, by the way, I just built I just built this fine-tuned version of a model. See if it gets picked up. Probably not. Oh, you know what? I did structured responses and integrated in my real-time React app. See if that gets a response. See if the interviewer is interested in it. Now you're getting instant feedback from your interviewers because you're trying to do as many interviews as possible, right? And that's a good way to get feedback as to what your audience really needs. And your audience being the company you're trying to get a job at. You could also do a LinkedIn search and just see what those companies are actually building. What are the tools and stuff that, would be helpful for you to make a good impression there. Even if you don't know anything in a lot of detail, but just the fact that you're aware and you're making incremental step towards it, it's so much easier to get a job. And the last path, along with the projects and the constant jobs, is go public. Speak. Try to speak at events. Try to network at events. Just going to an event is not important. Speaking at an event is important. Now, if you're like, oh, I don't have a topic to talk about, that's where a mentor comes in, because you start building something, you can automatically start talking about it. And a lot of organizers are so welcoming, right? They support young developers all the frigging time. But even if you don't have a topic to speak about, ask questions. Like if there's a good meetup with a good speaker and it's a topic which is similar to the project you're working on, ask detailed questions. The depth of your questions will be good enough to excite people enough that they talk to you. Right. And that's, I shouldn't be saying this aloud. Zebia, I'm going to be with you. Don't worry about it. But because of the questions I ask in some of the meetups, I got inbound job offers. They were just like, hey, it seems just the quality of a question suggests that you're thinking about these problems so deeply, and we would like to have somebody like that on board. Right? So try to do that. In short, keep doing your interviews. Use it as a feedback loop, not just as a means to get a job. Do projects which creates content, right? Which creates experience, which you can use in your interviews. And finally, do meetups. Try to talk and ask really good questions. Like prepare your questions before you go in. And of course, work with open source communities as well. Work with open source companies. Try to get in touch with these startup founders. Referral is the best way to get the best job.
Absolutely, yeah. Noorain, I have a couple of final questions for you.
Sure.
Number one, why does Python suck? So maybe also, I think maybe give some context. You come from a Go background, right? Go is your go-to language. No pun intended, right?
Yeah, it's my primary. Yeah. TypeScript being my secondary. Yeah. Okay. So I know where so on my streams, for anybody who doesn't know, I keep joking around with that Python sucks. Even with my guests, even though they're making libraries with Python, I'm like, hey, why Python? Do something better. It's a running joke, so I just stick with it at this point.
Okay, I see.
The truth is, which again, I'm letting you in on it, I do use a lot of Python because you have to. A lot of the data science stuff, a lot of the RAG stuff is still done in Python. But the reason is why do I portray that I hate Python so much? First, it's for content. It's for the memes. But on a more deeper level, I think it's the more fluid a language is, the harder it is to productionize it, in my opinion. Python, it's so easy to shoot yourself in the foot because first of all, in production, like if you're making an API and stuff, you want to go async because it's single threaded, right? You can't block the thread. Now, once you get into that, you have to make sure all your libraries, even though they support the async format, are they really async? Right? I noticed like in a lot of places, Llama Index blocked my thread. And that was a disaster. I ended up creating my own RAG stuff after that. But the point is, Python, because the ecosystem has been so fragmented across the data science world, which doesn't care about productionizing, the data engineering world, which cares so much about production, they don't care about developer experience. And finally, the API, the web development world with Django, Fast API, and things like that. It's so fragmented and everybody's trying to come together that it's so hard to choose and build a production-ready app, even for somebody like me. And I take pride in the way I architect my solutions, right? But it's really hard. Compare that to Go, you can't go wrong with Go. Every library in Go is just going to work. It's just going to work. It's a fixed philosophy. It's not different people from different perspectives. Everybody's writing the code the exact same way. No matter if you're a junior dev or a senior dev, you can read somebody's code and you can understand it.
Yeah.
I think that allows a team to move faster Because I work in teams, right? Like, I mean, I don't love writing code. I mean, I do write a lot of code, but I would rather not. And if I want a team who can write code alongside of me and keep up with me, I do want a language or a medium of communication which is easy for the interns or the freshers, because hiring engineers is expensive, but at the same time allows me to do complex stuff. And Go is like the perfect balance for me. And that's the reason why I didn't go with Rust either. I just stick with Go.
Interesting. Yeah. So, you mentioned 3 kind of groups of people that come into Python. It's actually interesting you mentioned that. So you have, data scientists, data engineers, and you have the third, which is the web API people.
Yeah.
Personally, I think the third is the worst reason to go with Python.
But then I have a question for you. Let's flip the roles.
Yeah. Go for it.
All the RAG stuff is really rich in Python, right? Right now, at least. But to deploy it, you would need to do the web stuff. What do you do now?
So 2 things. You can split them off as services, right?
But even the RAG stuff would need an API.
So I'll tell you what I do personally. Right?
Yeah.
I'll tell you what I do personally. For any stuff that's all that stuff, I found the ecosystem in TypeScript is quite good. So I use Node for a lot of that stuff.
For your RAG pipelines?
For a RAG pipeline as well.
Okay,
yeah.
That's interesting.
Now, with a caveat, just personally for our production use cases, our RAG pipeline, a lot of the RAG stuff we do is actually
not compute heavy.
Not compute heavy.
Got it.
And
okay.
So that's one big caveat.
Of course.
The other thing I'll say is that for our RAG pipelines, the ingestion portion is very compute heavy, but not necessarily the actual retrieval portions. The retrievals end up being quite trivial. So the language, it doesn't matter as much.
Right.
But I see where you're coming from. Like if your application relies on it, then definitely. And I'm not being like strict saying, okay, never use it, but there are cases where you have to.
Yeah.
But I think the tooling in TypeScript is getting quite a lot better for a lot of the reg stuff.
TypeScript,
there's problems with TypeScript and JavaScript ecosystem. That's a different thing too.
But
right?
it's manageable. Yeah. And it's mature enough, and the philosophy is still like it's an event loop, right? So everybody builds around the event loop, right? So it's not that you'll have to battle the event loop itself, because it's a first-class concept baked into Node.js, right? But with Python, async IO is an afterthought. It's not a part of Python, which means that a lot of libraries you'll have to start fighting with it. And the reason why, I started so dissing on Python so heavily is because a lot of people who start with Python and they've invested so much effort in building their RAG POC in Python that they're like, oh, you know what, let's just use it for productionizing it as well. Now, to be fair, a lot of the Python ecosystem is going to be powered by Rust, like Polars, and there are amazing tools out there which are powered by Rust. Folks aren't using it. They're still stuck on pandas and stuff like that, right? So they're not putting in those thoughts during the POC phase, and they're just using whatever's fast, and then they just take it and ship it to production, which annoys me. And Python requires a refactor. Yeah.
In language choice, I think the biggest choice is definitely your team, like who you have. I was mentioning this in the morning too, but if you have like a rockstar TypeScript or rockstar Python dev at your disposal, then let them do the language they're best at and abstract away the things that maybe don't need to be language agnostic.
Precisely.
Like we do use a lot of Python. Like when we're doing anything to deal with models, all the data science stuff, it's all Python, right? I'm not touching other languages for that. But,
absolutely.
As far as there are certain buckets for certain things.
Absolutely.
I just have one thing. Can you? I'm going to ask a question, and I wonder if you can defend Go for this. I'm going to say a column about Go, and you try and defend it.
Well, all right, let's try.
If error is not equal to nil, the amount of times I have to write that when I'm using Go.
If error is not equal to nil, yeah.
I find half of my Go code ends up being that. Now it might be that I'm just a Go noob, but I just find that everywhere. Is there maybe there's a method to the madness though?
Yeah.
That you can explain.
It's all about the philosophy, right? In Go, for people who don't know, in Go, errors are not something you throw as an exception. It's data. That's the key. Error is not an exception that you throw. It's data which you pass around. So essentially what you do is if your function is going to experience an error, it returns an error as data rather than throwing an exception. This has a lot of benefits just by looking at the code. By looking at a code, you know whether this function is going to throw an exception or not. How do you know that in Java world or Python world? How do you know a function can throw an exception? What if you forget to catch it? Problems, right? And often the programmers laziness kicks in, right? That they try to make a big try with a one single catch. But what if you want to have individual logic? Like, you want to handle each error in a slightly different way, right? So switch cases, that's how we do it, right? That's how we do things. And if your error was data, you can do switch case on the error object directly. So it just makes error handling so much more intuitive in the way that you can see it in your code. You don't need to guess, you don't need to assume things. Go loves explicitness. Whatever you see, and that's why Go has one of the most verbose syntax, right? But whenever you read Go, there's no ambiguity of what's happening. Right. For each statement, for SQL query 1, you have an error. And if, of course, there could be like a connection error or there could be like a parse error. So you could have a switch case on the error type directly and be like, oh, if it was a connection error, then do this. If it was a parse error, then go back to the LLM to generate a new query. So much easier to think about it, right? Connection error requires a back off. Parse error requires an immediate retry. How do you do these things in any other language, right? It's so much. I mean, you can do it. It's just inconvenient.
Right, yeah.
So that's. I mean, I just love the beauty of explicitness.
The way a lot of the other languages deal with it is to wrap it around the framework, though. Right. Yeah. So you install the frameworks and the framework abstracts it away for you, which is both a good and a very bad thing.
Yeah. In Go, we avoid, like all Gophers avoid frameworks. Like, for example, most of the popular frameworks out there just use the net HTTP, the standard library.
For API,
like the standard library is our gospel of truth. We'll try to stick with it as much as possible.
Yeah.
We don't like frameworks because that limits my ability to be flexible. And I want to be able to express whatever I want to do as quickly as possible. And the fact that this makes the code so simple is it makes it easy for things like Cursor to walk through it and generate code and stuff like that. It doesn't have to reason a lot. Like try navigating a Rust code base. It's just not possible.
Rust is great at a lot of things. Like it solves a lot of things and makes things performant.
Yeah.
In a world where you don't necessarily have to write C++ on everything. But it is hard to read. Like I see a lot of libraries and tools I use that are written in Rust, so I'll have to clone them and see why is what's happening here.
Yeah.
And it is not the easiest to read for a non-Rust developer.
So actually, Rust has this crazy learning curve where for most tools you learn and you get it and then cool, you get it.
Yeah.
But for Rust, you're like, oh, borrow checker, we need to learn the borrow checker. You figure it out. You figure out how pointers work. You figure out how mutable stuff work. And you're like, oh, I got it. And suddenly comes async. Suddenly comes in Tokyo and you're like, oh my God, everything I learned, throw it in the bin. Because async is like a completely different beast in Rust. I mean, but again, I'm not saying Rust is bad. I still some parts of my tool chain is in Rust, especially where I want to control the memory. But it's not my go-to tool is always going to be Go.
Right.
But I have some conditions where I'm like, okay, let's not try to do these things in Go. Like for example, if I want to do EDA, like explore by data and do some analysis, I'll do it in Python and Marimo notebooks. If I want to do something with front end, I'll just use TypeScript. Right.
I need to look into Marimo notebooks, by the way. It'll remind me about that again.
You really need to check it out. It's amazing. I love it.
Because I'm still in Jupyter Notebook land. So
I can't use Jupyter anymore. Okay. I just can't do it.
Jupyter Notebooks and Colab is still the EDA for me, but I'll have to look into it.
Marimo is good.
Nice.
It's worth it.
So, Noorain, so obviously there's a lot of tools that come up, and as part of your streams and also things, you have to keep up with a lot of things, right? And even some of the ways I keep up with things is like, okay, for example, UV, right? I wanted to switch to UV. I knew UV was good, and it wasn't until your stream where I was like, okay, this is what everything it can do. So you kind of condensed that learning curve for me, right? So I'm like, okay, if Noorain approves it, then it looks good in the stream, I'll just switch to it, right? So you took that thinking, that learning kind of out of my hands.
Yeah.
And I know you're probably doing this for a lot of other people as well. But how do you personally look into, because you have to look into a lot of frameworks, decide what, might be worth investing. And then you have to, prior to a stream or prior to, you using it, you probably have to go play around with it yourself.
Yes.
Do you have some structured way where you go about this, or are you just like, go ahead.
It was a very haphazard way that I used to do it. But I've realized that the problem of this AI space exploding, it's twofold. So one is awareness of what's happening. And the second is appreciation of what's happening. Appreciation only comes with depth and experience, right? For example, MCP. A lot of people are like, wait, why is MCP so cool? Like, we don't get it. It's just a protocol. What's the big deal about it? But the moment you get into, oh, wait, you can auto discover tools and you don't have to integrate it every single time you want to add a new tool. It just works. That's mind blowing. Uh, so what I've started doing for my stuff is, of course, it's my. You look at my YouTube feed, it's crazy. YouTube is my primary way to do it because I'm a YouTuber and I wanna focus on content which other YouTubers do because I'm still trying to catch up. I'm nowhere the person who will cover the tool the first day it comes out. I'm not that kind of a guy. Okay, if you want to do it, there are a lot of other people who are way better than me for it, right? But what I like to do is I see what's out and then I build a list. Okay, a laundry list of tools. And then comes in my best friend, Notebook LM. Just love that freaking tool. That allows me to get some depth enough that I can start forming opinions. If I'm confident, I'll reject it or continue with it. But if I'm still like a little like iffy about it, then again, that's time consuming. But a YouTube feed or your Twitter feed or like a Google Discovery feed or the news feed, like some kind of feed which of people who cover the tool as soon as they come out just to make a list of tools. I don't rely on them to understand the tool because it's hard to get the depth and the appreciation on day one. It's just hard. You need to mess around with it. And then using Notebook LM to, get all the podcasts, all the documentation, everything in one place and dissect it gives me the depth.
So in Notebook LM specifically, like you throw everything in there. Which features do you use? Like, do you actually use the auto-generated podcast? Do you use like the actual flat? Like, which parts of it do you use? Or are you just chatting with the base? Like, walk me through that actually.
How do I use? So I'm gonna do a stream on that soon.
Okay, nice. Okay,
but I'm still trying to figure out my way around it because I don't have a pattern yet. It's very random. But I'll tell you what are the different things I do, and then we can figure out the order in which to do it later, right? But what I do is I add all my sources at once.
Yeah.
And the way I add sources is go in incognito mode on YouTube and on Google and just put in the tool's name. You get a bunch of podcasts. You'll get a bunch of documentation sites, blah, blah, blah. If you have a documentation site, then you use Google Deep Research because that's helpful in discovering different things as well. I'm a big Gemini shop. So I get all that information and I just dump it in Notebook LM, but I don't chat with all the sources at once. I have a fixed prompt which says, what are they talking about? Don't summarize it. Just tell me what they're talking about. Like, don't give me judgment of whether it's good, whether it's bad. Just tell me what they're talking about. And I do it for each source individually.
Oh, I see. So as you're adding them, or you actually say the source, you cite that exact source and say what are they talking about?
In Notebook LM, you have a checkbox against each source.
Yes, yeah.
So I add all the sources at once because it's easy to add. It's easy to add everything at once. Yeah. But then I just checkbox each source and just run the same prompt again and again and again and again. And once I know that, okay, now you start forming an understanding once you know what they're talking about, right? Yeah. Some sources will be like, wait a minute, I need to watch this entire video. Even if it's a 1 hour video, it's worth watching it, right? I'll go ahead and watch it. If the stuff they talk about is cool, or if it's like, oh, this could be cool. Some sources are just neglected. I just remove it right away. And once I have that, then I start, using all the sources and say that, okay, now tell me what developers would be interested in, or tell me what problems they're trying to solve. So I have like standard prompts. I copy paste all my prompts. Yeah. I've got like a big Notion page where all my prompts are written one after the other. Nice. Just copy and paste it. That's how I use it. The audio stuff, I think as a YouTuber who's trying to build his own opinions, the audio stuff misleads me. I tried doing it, but it started conditioning me, and I don't want to do that. So text, as a human, you just skim through the text, right? You just look at the bold stuff or the bullet points. You don't and my prompts also make sure that, it's not going to give me an opinion. It's just going to give me facts. But the audio starts with opinion, which is good for the audience of my YouTube channel. So if my YouTube channel wants to do something similar, they would love the audio feature of Notebook LM instead of watching my YouTube videos, right? Yeah. But the problem with that would be that they will have to do all that research. Yeah. So what I try to do with my YouTube videos is I take my time. I might be like a week or two late. I might be a month late in some cases. Like small agents, I still haven't covered it. I want to cover it really bad, but I still haven't covered it because I'm still trying to figure out a good use case, like exactly where to use it, right? But you'd have to go through that effort of Notebook LM. So what I do is, you know what? Trust me, I'm going through that Notebook LM phase. And once I gain your trust, hopefully my weekly streams becomes your source of information. In the sense, you don't have to worry about the distinction between awareness and depth or appreciation. You can use my stream. I went from a 10-minute video to a 1-hour video, almost like a 40-minute video. So you can use that time of me struggling, of me, exploring the tool, going deep into it to build your appreciation or to build your opinion. That's the thought process.
And I personally do that, by the way. Like for UV, that was your stream was the thing for me, right?
I'm glad.
And then I knew BAML. Obviously, I've been working with BAML for a while, but BAML was like reinforced by your stream. And then other even things not like Pydantic AI, LangGraph. These were things that I'm like, okay, what's I know that Noorain is going to be genuinely like immersed in this and go through this.
Yeah.
Because I don't necessarily have time to go through every tool, right?
That's
when
true.
a tool is good, I will go through it and then I'll build my understanding if there's a use case for it, right?
That's true.
But I've been using that. And before you, I was still the same way. I would use find some other YouTuber who covered it and talked about it. But now it's you. I trust you. I trust your community, and so I can, be pretty confident that if Noorain says something is really bad for some reason, which I don't think you said that yet. Maybe for some things. Maybe for Python. Maybe for Python. But then I know I can just not touch it, right? So
absolutely. Absolutely.
Noorain, I think we covered a lot of what I wanted to talk about. There's still way more we could have gone to rabbit holes, but we'll leave it at that. Thanks so much for coming on, and
absolutely.
Definitely check out Noorain's channel. So YourTechBudCodes. His community on YouTube, definitely a great source of inspiration for a lot of people.
Absolutely.
Sweet. Thanks so much, buddy.
Thank you so much for your kind words, and it was amazing. This chat was amazing. Thank you so much for having me.